A very good morning to all of you. I cordially welcome you all for this classroom discussion topic. In the today's class, we have to discuss about how can we define the irreversibility, and similarly how can we define the second law efficiency, and how can we define the Gibbs function and Helmholtz function. And the motivation behind these topics are, so it is important to know how to estimate irreversibilities which are presented within the system, and similarly how can we estimate the second law efficiency, and how can we find out or how can we define the Gibbs function and Helmholtz function. So the outcome of the today's lecture is, so you should be in a position to determine irreversibilities within the system and define second law efficiency and Helmholtz function and Gibbs function. So how can we find out the irreversibility, or first of all, how can we define the irreversibility? So here the actual work which a system does is always less than the idealized reversible work. So the difference between the maximum work and the actual work is known as irreversibility. Because whenever we are finding out from the Carnot cycle what should be the maximum work which can be expected from a heat engine, so that is under the ideal conditions. So, but whenever we are executing the same heat engine in the actual practice, so that will deliver the lesser amount of the work as compared to the work which is produced by the Carnot heat engine in the ideal case. So the irreversibility says that always due to the presence of the friction and due to the heat transfer through a finite temperature difference and due to some other dissipative effects, so the actual work is always lesser than the maximum amount of the useful work. So the difference of these two is basically defined as irreversibility. That is, this much amount of the work is lost, or this much amount of the work is degraded or dissipated into the surrounding atmosphere due to the presence of all these particular effects. So first of all, you should be in a position to define comfortably the irreversibility. So irreversibility here, the definition is very clear. It is a difference of the maximum work and actual work. That is a W stands for here actual work. So the difference of maximum and actual work is equivalent to irreversibility. That is how much amount of the work is lost to the surrounding atmosphere due to the presence of all these friction and other dissipative effects that can be found out by using the irreversibility. So that is the importance of studying the irreversibility. So now by deriving all these things, we are able to find out the irreversibility is equivalent to always T naught into delta S. So delta S universe, delta S universe. So delta S universe is nothing but delta S system plus delta S surrounding. So that's why the irreversibility can be written as T naught into the delta S universe, that is nothing but delta S system plus delta S surroundings. So now based on this particular one, so here you are able to see that is a UPSC, that is a Union Public Service Commission, that is IAS examination. So he has asked one question based upon the irreversibility concept. So what is the question? Just we will go through that. 1 kg of air is compressed polytropically from 1 bar. So first of all, you write down the given data. The given data is missing here. First of all, you have to write down the given data. So mass is equivalent to M is equivalent to 1 kg, and P1 that is a 1 bar, and T1 300 Kelvin, and P2 6.8 bar, and T2 370 Kelvin. Determine the irreversibility if the sink temperature is 293 Kelvin, that is the T naught, as the surrounding atmospheric temperature is 293 Kelvin. So now he is asking about determine the irreversibility. So we studied that irreversibility is nothing but is a difference between the maximum work and the actual work. So first of all, let us find out the maximum work which can be produced from this particular process. So how can we find out the maximum work? So here the maximum work is nothing but is a change in internal energy minus T naught into change in entropy. That is the reversible work is nothing but U2 minus U1 minus T naught into S2 minus S1. You know that the internal energy formula is a CV into T2 minus T1, and here because it is taking place according to the same process. So S2 minus S1, that is the change in the polytropic process, because it is the polytropic process is taking place, and we studied the entropy change during the polytropic process as Cp log T2 by T1 minus R log P2 by P1. So you know all the values here. So first you find out the maximum amount of the work which is produced by this particular system, that is equivalent to 149.53 kilojoules per kg, is the minus sign. So you know that what we mean by the minus sign, that is the work done on the system. So here on the system means it is the work done on the air. So how much work is done on the air is 149.53 kilojoules per kg. So that's why it is minus. Now W max is already over. Now the next part is we have to find out the actual work. That is the W actual. So what is the formula for the W actual? Because it is a polytropic process. So in the polytropic process, how can we find out the work? That is the P1 V1 minus P2 V2 by n minus 1. Because it is the air, we can treat air as an ideal gas. So PV is equivalent to MRT. So MR T1 minus T2 by n minus 1. But here he has not given the polytropic index value. Simply mentioned only the polytropic process is taking place. So we have to find out the n value. How can we find out the n value? So once again, just you go through the PVT relationships of the polytropic process, in which we can know that T2 by T1 is equivalent to P2 by P1 whole to the power of n minus 1 by n. So from this, n is equivalent to 1.123. So just you substitute here, we got W actual is equivalent to minus 163.33. Now the main task is to find out the irreversibility. So W reverse minus W actual. So from this we are able to find out that 13.8 kilojoules amount of the heat is lost from 1 kg of the air due to this particular the polytropic process which is taking place according to the irreversibility. So next one is the another important concept is the effectiveness. So how can we define the effectiveness? So effectiveness is defined as the ratio of actual useful work to the maximum useful work. So it is a W actual divided by the W maximum useful work. So here we can have the effectiveness is equivalent to increase of availability of the surroundings divided by loss of availability of the system. So in general, we can say that effectiveness is equivalent to useful work divided by the maximum useful work. So always effectiveness of an actual process is always less than the unity only. So based on this particular one, so we completed the irreversibility concept and effectiveness concept. The next one is the Gibbs free energy. So Gibbs free energy is a measure of chemical energy. It is a measure of the chemical energy. So that is all chemical systems tends naturally towards state of the minimum Gibbs free energy. So Gibbs function is normally defined as it is H minus Ts. You have to remember H minus Ts. So H is equivalent to enthalpy, and T is equivalent to absolute temperature, and S is equivalent to entropy value. So it is called as the free energy. It is called as the free energy. That is the Gibbs free energy. So it is the measure of the maximum magnitude of the net useful work that can be obtained from a reaction. That is why we have to study the Gibbs function. What is its importance? So that is, it is a Gibbs function. It is a measure of the maximum magnitude of the net useful work that can be obtained from a reaction. So next one is the Helmholtz function. So Helmholtz function is represented here A, and in some textbooks they will be taken as F. So whatever that may be. So here A is equivalent to U minus Ts. So what is the difference between the Gibbs and Helmholtz function? In the Gibbs function you are having here H minus Ts. And in the Helmholtz function H is replaced by U, that is a U minus Ts. And Helmholtz function is also, it is a free energy concept. So Helmholtz free energy is a thermodynamic potential that measures the useful work obtainable from a closed thermodynamic system at a constant pressure and volume. So here, how can we define the second law efficiency? Because the last concept is the second law efficiency. How can we define the second law efficiency? So here the second law efficiency is basically defined as it is the ratio of the minimum available energy which must be consumed to do a task divided by the actual amount of available energy consumed in performing the task. That is, second law efficiency is nothing but A minimum by A. And here the another 8.87 is a very important equation, that is what is the relationship among first law efficiency, second law efficiency, and Carnot cycle efficiency. So in what way second law efficiency is different from the Carnot cycle efficiency and from the first law efficiency. So here we can find out the relationship. The second law efficiency is equivalent to first law efficiency divided by the Carnot cycle efficiency. That is, if you want to calculate the second law efficiency, so then the first law efficiency should be known to you, and similarly the Carnot cycle efficiency also should be known to you. So like this, we are able to define the irreversibility concept, effectiveness concept, second law efficiency, Gibbs function, and Helmholtz function. So all these are very important one whenever we are dealing with the availability concept. So I hope you understood these particular concepts. So thank you one and all for listening this lecture, and we will meet you once again in the next classroom discussion topic. Thank you.